welcome to BYJU'S Exam Prep, and I welcome all for this particular session, which is GATE Champion Series, and we are talking about Discrete Mathematics. I think I am audible, visible. GATE Champion Series, Discrete Mathematics, and the topic of today is counting. So yesterday we completed logic, so let us take up some interesting problems on counting. Hi Anant Mohan, very good evening sir, very warm welcome to you. Yesterday I forgot to bring that. Towards the end we will discuss those problems. I'll copy and I'll do that. Okay, yesterday's homework. How many problems I given? 3 problems, right? I didn't give the solution, right? Today I'll share that. I thought, some people give me the solutions in the chat box. No one given the solutions in the chat box. So no one given the answers for those solutions in the chat box. So I was waiting for your solutions. Okay. So today at least I expect you to give solutions in the chat box, my dear friends. Not chat box, in the comment section. Please write your solutions in the comment section. Towards the end, I'll discuss those problems for sure. Okay? Towards the end, I'll discuss the solutions. Or in between. Don't worry. And this is about me, myself, Sridhar Sir. I'm having 20 plus years of teaching experience, and my qualifications are MTech Saka from NIT Karnataka Surathkal and MSc Mathematics from JNTU Hyderabad. And these are my qualifications, achievements, and these are all my areas of expertise. See, my dear friends, I am associated with BYJU'S Exam Prep. Actually, BYJU'S from past 1 year, we are working on a different project called GATE Recorded Content. This is the first of its kind. We created visualized animated content for you. Under BYJU'S Exam Prep app, very good sir, very good. Very good Anand Mohan, I like that. Yeah, I'll check it out. Okay. You can find all these subjects which were recorded by me under BYJU'S Exam Prep app, Learn with Video Lessons category, my dear friends. Okay, there you can find all these. Yeah, Ashprit, welcome, hello. C and data structures. Right, and, oh sorry, this is not for you. Let us solve problems for today. How many 3 digits even numbers have all 3 distinct digits, or all 3 digits distinct? Some of these are regular questions, very interesting GATE questions, so modified. Hi Gordon, good evening sir, very good evening sir. Good to see you back, and good to see you, see all of you back, my dear friends. How many 3-digit even numbers have all 3 digits distinct? Any answers please? Any answers please? See my dear friends, you want 3-digit numbers where all the 3 digits distinct. See, if you take normally without any condition, without this even number condition, how many 3-digit numbers are there with all the 3 digits distinct, my dear friends? See, 3-digit number means the first digit cannot be 0. So here we have 9 choices. Whereas the second digit, how many choices we are having, sir? Because here 0 is not allowed. But here 0 is allowed and remaining 8. That is 9 choices we are having. And here how many choices we are having, sir? 8 choices. So 9 into 9 into 8. So what is that answer, my dear friends? Can you please tell me this answer? 9 into 9 into 8. What is this answer? Number of 3-digit numbers having all the digits distinct. All distinct digits. Yes, very good Ashprit. 648 is the answer. But that is not answer for this problem, because here we want very good Mohan, very good. Here we want even numbers. See, actually even number is little difficult in the sense, I'll tell you that method also, but odd is easy to find. So first let us find out 3-digit odd numbers. 3-digit odd numbers with distinct digits. With distinct, hi Bhupinder, your answer let us check. With distinct digits. So 3-digit odd numbers with distinct digits means, because it is odd number means it should end with either 1, 3, 5, 7 or 9. That is how many choices we are having for the last place? 5 choices we are having. 5 choices we are having. Right? Next we have here 0 is not allowed. So other than 0, how many we have? Because already one fellow is filled here. 8 choices we have. Here how many choices we are having? 0 can come, so 8 choices we have. 8 into 8 into 5. So 320 choices we are having. So there is some noise today because there is some Nimajan going on. So there is some noise pollution. Sorry for that. Yeah. So he asked even. What is the question which he asked? Not for continuously, sir, for some time. Okay. 3-digit even numbers with distinct digits. So it is total minus odd. Total is 648, odd is 320. Yeah, with background noise today, because in my society only some what do you call this, Ganesh Nimajan, what do you call, that is happening, so sorry for that. So what is it? 328. 328. So 328 not option, 328 is option C. Oh, A someone said, B someone said, but no one given this 328 answer. Why? Why we are getting different answer than you? Due to noise background? Or due to background noise? Nowadays they are calling it as BGM. So C is the answer, not okay, B. See, this duration is around 1 hour, sir. We have few problems which we complete and then we can move on to the next. Okay, like that. See, actually, if you want to solve this directly, okay, if you want to solve this directly, we need to understand the story is like this. When it is even number, it can either end with 0 or end with 2, 4, 6, 8. Am I clear? See, ending with 0 and ending with 2, 4, 6, 8 are two different stories. See, ending with 0 means it can end only in one way. And for the first question, because 0 is already filled, there is no problem at first question. So 9 choices. Next question, 8 choices. Am I clear? So that is what happens when it ends with 0. But when it is ending with either 2, 4, 6, 8, last question is having 4 choices. But for first question, you have to stop 0. So here for first question, 1 is already filled, 0 is not allowed, 8 choices we have. Next question, 7 plus 0, that is 8 choices we have. 0 means 0 is also a choice. 7 plus 1, 8 choices. So if you want to solve this problem directly, the answer is 9 into 8 plus 8 into 8 into 4. So because of this, the answer would be different, sir. Oh, no problem. No problem, sir. So what is the answer? 328. So similar problem was asked in GATE with 4-digit number. I made it much easier for you, taking 3-digit number. Taking 3-digit number. Oh, no problem. Super. Next one. How many non-negative integers less than 10 power 3 contains the digit 1? How many non-negative integers less than 10 power 3 contain the digit 1? Try this. Waiting for your answer. I have no other work to do except listening to background music. Yeah, what's the answer, sir? C. Arshpreet says C. Arshpreet contains the digit 1. Contains the digit 1. See here, direct is very complicated because 3 digit less than 10 power 3 means what, sir? 10 power 3 is 4 digit number. Less than 10 power 3 means? Less than 10 power 3 means it can be 3 digit number or 2 digit number or 1 digit number. And again, containing 1 means 1 digit number containing 1, 2 digit number containing 1 once or twice, 3 digit number containing 1 once, twice or thrice. This many cases you have to solve it. Maybe by tomorrow, okay, you may get the answer for this problem, my dear friends. Directly is a very complicated problem. So what we do, we go indirect. We go by indirect method, my dear friends. So what we do here is, what sorry, we first find total. What is the total? Number of non-negative integers, number of non-negative integers less than 10 power 3. Non-negative means 0 is also included, my dear friend. From 0 to less than 10 power 3 means 999. So 0 to 999, how many numbers are there? How many numbers are there? Of course you can say 1000 numbers are there, but for that I will give you a method. See, maximum it is 3 digit number. Maximum it is 3 digit number. So you can do 3 digit number plus 2 digit number plus 1 digit number. That is one way of doing it. But what we do is, normally for 3 digit number, we say that there are 9 choices for this. We say that there are 9 choices for this. Okay, with 9 choices you get all the 3 digit number. But if I include leading 0 or if I allow leading 0, the 10th choice can make it 2 digit number also. So to get the 2 digit and 1 digit numbers also, what I do is I allow leading 0. So the logic here is, we write like this: by allowing leading zeros, we get 3 digit, 2 digit and 1 digit. Okay, not 3 digits, sir, because when you allow leading zeros, we get 2 digit and 1 digit numbers also. Is the idea clear? So with this, what happened? 10 choices for this. For each of the 10 choices, there are 10 choices for second position, there are 10 choices for third position, total 10 cube choices, my dear friends. This is total. But what you want? What you want? Containing the digit 1. So what you do is, not containing digit 1. You find number of non-negative integers less than 10 cube, not containing digit 1. Not containing digit 1 means 1 is not allowed. So how many choices for this? 9 choices, 9 choices, 9 choices. So the answer for this would be 9 cube. And what is your answer? We want contain the digit 1. When you want contain the digit 1, how to get contain digit 1? Number of non-negative integers less than 10 cube, contain the digit 1. How can you get it? From total, you remove do not contain 1. Do not contain digit 1. And both are ready, which is 10 cube and this is 9 cube. So 10 cube is 1000, 9 cube is how much, sir? Now I think you understand the solution for this problem. What is the solution? What happened? Is it difficult? 9 cube is what? 81 into 9. 729, no? 729 means 731 less 271. Why people are not answering, sir? 271. Did I give that option? Yeah, option A. It is called indirect counting, one of the important approach. Very good, Aspirants. 1000 minus 729. The similar question was asked in GATE, but I modified slightly so that we can answer this question also. The number of 4-digit numbers having their digits in non-decreasing order from left to right, constructed by using the digits belonging to the set 1, 2, 3, 4 only. It's a numerical answer type. See, generally from counting you cannot expect much of MSQs, my dear friends. Multiple select questions are very, you can say not, generally you don't expect any multiple select questions from this. Not possible. Logic, graph theory or other topics it is possible, but for counting, generally either numerical answer type or MSQs we can expect, my dear friends. Mostly that type of questions only possible here. Yes, 4-digit numbers having their digits in non-decreasing. Non-decreasing means increasing with equal fellows together. Non-decreasing means increasing with equal fellows together. So, you are making numbers only with 1, 2, 3, 4, sir. 4-digit numbers you are making. Am I clear? Constructed by using digits belongs to the set 1, 2, 3, 4 only. Non-decreasing means increasing with equal fellows together. Means here we can also have repeated numbers, my dear friends. We can also have repeated numbers. Sir, Tushar Garu, Tushar Sisodia, very good evening, sir. There are some more people who regularly attend the class. Okay, I am not regular nowadays on YouTube after C programming. I'll start, sir, because we have one more session on this. What is it? What is that one more session? Algorithms. GATE Champion Series algorithms. I'll come up with some good problems there also. Okay. Maybe not next week. Next week we'll have that. Okay. After 1 week we can have that. See, 4-digit numbers having their digits in non-decreasing order, constructed by using the digits belonging to the set 1, 2, 3, 4 only. 1, 2, 3, 4 only. So what about this, sir? You want to construct 4-digit number. Means you have to fill how many positions, sir? 4 positions you have to fill. But only 1, 2, 3, 4 are allowed. Increasing order may be equal fellows together. For example, if you start with 4, for example, if you start with 4, 4, 4, 4, 4, only this 4, 4, 4 we are going to get. Okay, it will be announced at Ashprit. Algorithms will be announced. Okay, 4, 4, 4 only. Because you cannot decrease the number. We can only have equal or increasing. Because maximum is 4 only. So this is what happens. But when you start with 3, next number can be either 3 or 4. But once it is 4, the next two numbers are 4 only. But again here it is 3 means again 3 or 4 is possible. But once it is 4, it is fixed. But here again 3 or 4 are possible. That is, with 4 only one number is possible. But with 3, 1, 2, 3, 4 numbers are possible. 4 numbers are possible. So similarly you can try with 2 and 1 also, like this, my dear friends. Where by the tree diagram you can answer this question, my dear friend. By tree diagram you can answer this question. But let us solve this using recurrence relation. Let us solve this using recurrence relation. This would be little difficult and it requires dynamic programming approach. So what I do is I try to take same problem under algorithms also for dynamic programming. We can take some additional interesting examples for dynamic programming, like Fibonacci series is there, NCR, R combination of n objects is there, this problem is there, coin change problems are there. There are many problems we can take under this dynamic programming approach, my dear friends. Am I clear? Recurrence relation. See here what I do is, if it is starting with 1 and 1 digit number, how many 1 digit number starting with 1 are there, sir? Only one fellow will be there. If it is 1 digit number, only one fellow will be there. Starting with 2 1 digit number, see starting with 1 1 digit number is 1. Starting with 2 1 digit number is 1. Starting with 3 1 digit number is 1. Starting with 4 1 digit number is 1. But when it is starting with 4 2 digit number, see this second subscript tells you what about the number of digits. First subscript tells you what is the digit, with what digit you are starting. So when it is C42, it is starting with 4 2 digit number. Obviously when it is starting with 4 2 digit number means the first digit must be 4 only. So obviously it should be C41 only is the possible. That is 1 plus C41. What is it? It is 1 plus C41. Oh sorry, not why 1 plus, sir, same thing na, only 1 will be there. That is C41 is the only one. C41 is 1. But when it is starting with 3 2 digit number, starting with 3 2 digit number, it can be 1 digit number which is starting with 3, or you can have 1 digit number which is starting with 4. So it is combination of 1 digit number which is starting with 3 or 1 digit number which is starting with 4. 1 digit number which is starting with 4. If you understand this logic, we can write the generalized recurrence relation for this, my dear friends. For example, Cij means what, sir? Starting with I, j digit number. Starting with I, j digit number when you take it. Any fellow when it is starting with I, j digit number, the next fellow would be, it is I, starting with I, j minus 1 digit number, that is same number is the next number. For example, if it is 3, next number can be 3 or more than that. Next number can be 3 or more than that. And what is the maximum value, maximum number of digits possible in the set? That is 1, 2, 3, 4, now maximum number of digits possible in the set. Let us call this maximum number is say k. Let us call this maximum number for generality is say k. Now, this is Cij minus 1 plus Ci plus 1 j minus 1. Like this we can continue, my dear friends. Now if you want to write it as a summation notation, you can write it as sigma. Okay, from where to where it goes, sir? It goes from I to, or let me put some general value for this. It will go from where to where, sir? It has to go from I, it has to start from I and it has to continue till what, sir? It has to continue till the end of this number of numbers. Wherever, if you may be 2, so 2, 3, 4 you can take it. 2, 3, 4 you can take it, sir. So this value of I can be, or you can say k, no, let us put this as k. So this value, or let us call it as some k. So where k varies from I to last number. Okay, here I am calling it as n. Let us make it as n, sir. I to n. K j. Am I clear? K j minus 1. K j minus 1. Because 1 digit less than that we are going to do. So with this you are going to get the recurrence relation, my dear friends. And it would be looking little difficult, but let me solve this very easily with the table value, my dear friends. 1 digit number, starting with 1, starting with 2, starting with 3, starting with 4, 1 digit number. Okay. I need space. I'll just remove this and write it somewhere else. Maybe here I write it. Sigma Ck j minus 1, where k varies from I to last number. Last number I am calling it as some n, so it goes up to n. 4 what? What is 4? See here you see the question, sir. 4 digit number using 1, 2, 3, 4. 4 digit number using 1, 2, 3, 4. Hope you understand. 4, you are saying 4 is the answer. 4 is not the answer. Let me tell you now. Now, starting, these are the starting numbers, sir. Starting numbers. This is starting number and this is number of digits. On y-axis you are having number of digits. Number of digits. Okay? So, let me write it a little further. Now starting with 1, 1-digit number is 1, starting with 2, 1-digit number is 1, starting with 3, 1-digit number is 1, starting with 4, 1-digit number is 1. Now if you want 2-digit number, always start from 4. Starting with 4, 2-digit number is 1. But starting with 3, 2-digit number, if you want it, 3 with 1-digit number, 4 with 1-digit number. This plus this, you need to add these two, you are going to get this answer too. And for this, starting with 2, 2-digit number if you want means starting with 2, 1-digit number, starting with 3, 1-digit number, starting with 4, 1-digit number. Means sum of these fellows, 1, 2, 3, sum is 3. Similarly, starting with 1, 2-digit number if you want, it is starting with 1, 1-digit number, starting with 2, 1-digit number, starting with 3, 1-digit number, starting with 4, 1-digit number. That is simply sum of these fellows because you already stored. So the answer here would be 4. Next one is 3, 3-digit number. So here when you want 3-digit number, 4, starting with 4, 3-digit number is 1. But starting with 3, 3-digit number means it is starting with 3, 2-digit number or starting with 4, 2-digit number. That is just sum of these two fellows, 2 plus 1 which is 3. So now you understand, you can simply write down the answer, sir. Next one is what, sir? 1 plus 2 plus 3, that is 6. Next one is 1 plus 2 plus 3 plus 4, that is 10. Now you want 4-digit number. Here also 1, 1 plus 3, 4, 4 plus 6, 10, 10 plus 10, 20. So this is starting with 1, 4-digit number, starting with 2, 4-digit number, starting with 3, 4-digit number, starting with 4, 4-digit number. But he is asking all 4-digit numbers. How many 4-digit numbers are there? Just add these fellows. 20 plus 10 plus 4 plus 1 will give you number of 4-digit numbers which is 35. These are number of 4-digit numbers with the given condition, my dear friends. Number of 4-digit numbers with the given condition. Hope you understand. Hope you understand. So let us solve the next problem. What about the solution for this problem, my dear friends? Yeah. Next problem solution, sir. Next problem solution. People are interested only in the simple problems. Okay? Even a small complications, people are not able to bear it. So we should always go with simple questions. How many number of positive integral factors are there for 2022? See, this is a very regular problem, sir. What you do is you do factorization for 2022 this year. 2 ones, zeros, ones, ones. 1 0 1 1. You call it as prime factorization. What is it called? Prime factorization. Now 2 does not go. Then comes 3. Yeah. 3 3 is 9, 11, 3 3 is 9, 21, 3 seconds. Now you need to check whether 337 is a prime number or not. If it is not prime number, you have to find the factors for 337. See, generally to check whether it is a prime number or not, you roughly take square root of 337. What is square root of 337, my dear friends? Approximately 337 square root is how much? 337 square root is how much? Approximately it is 18. So square root is approximately 18. So what you do is up to 18 you take all the prime numbers, check whether it divides 337 or not. Check whether it divides 337 or not. So like 2 does not divide, 3 does not divide, 5 does not divide, 7 divides, 7 does not divide. Okay, next 11 does not divide, 13 no, 17 no. So if none of them divides, then it is a prime number. So the prime factorization for 2022 is 2 into 3 into 337. This is the prime factorization for 2022, my dear friends. This is the prime factorization. Am I clear? Now, if you want to know number of distinct integral factors, number of distinct integral factors. What you need to do? You just see the powers, power 1, power 1, power 1. So just add 1 to each power. That is 1 plus 1 into 1 plus 1 into 1 plus 1. That is 2 into 2 into 2, that is 8 is the answer. There are 8 positive integral factors, or there are 8 positive integral factors or divisors of 2022, my dear friends. Good. Can you tell me some of those integral powers? Can you tell me some of those integral powers? Or some of those integral factors, not powers, factors, some of those integral factors. Can you tell me some of those integral factors? You want to understand this step, Ashpreet? See, you write down the prime factorization. In the prime factorization, you see the powers. You first write down the prime factorization. Up to here, prime factorization is clear, Ashpreet? Up to prime factorization, is it clear? Once you do the prime factorization, you see the powers. For each power, you just add 1. For each power, you add 1. For each power, you add 1 and multiply. That will give you number of distinct integral factors, my dear friends. That will give you number of integral factors. Okay, 342. Yeah. Now the sum of integral factors, if you want to do it, sum of integral factors you have to do it. For that, the simple logic is, you got the prime factorization, no? You got the prime factorization, no? What you do is, you just write down, highest power is 2 power 1, no? You start from 2 power 0, 2 power 1. Next into 3 power 0, 3 power 1. Next into 337 power 0, 337 power 1. You expand and multiply, that will be the answer, my dear friends. Yeah. Not 342 Anant Mohan. The answer would be different. The answer would be this. So if you want to get this answer, it is 2 square minus 1 by 2 minus 1. Geometric sequence. 3 square minus 1 by 3 minus 1. 337 square minus 1 by 337 minus 1. And that would be the answer, my dear friends. That would be the answer. Why 1 will be added only once? That is 1 plus 2, na? 1 plus 2 is nothing but 2 square minus 1 by 2 minus 1. Yeah, 1 will be added for every power, once it will be added. For every power, 1 will be added. For every power, 1 will be added. For every power, 1 will be added. Yeah, only once. But here, for some of those positive, some of those integral factors, if you want, you need to do this. If you actually expand, you will get that, my dear friends. Otherwise, you can simply do, see, instead of doing it, this sum is direct, simple, no? If you don't like it, that is very complicated, you can do now, it is directly what, sir? 1 plus 2, 3. And this is 3, 1 plus 3, 4. And it is 337 plus 1, 338. You can simply do this, my dear friends. Yeah, 4056 is the answer. Whatever way you do it, you will get the same answer, my dear friends. Anant Mohan, is the idea clear? Anant Mohan. about this. What is the minimum number of students in a class to be sure that 3 of them are born in same month? 3 of them are born in the same month. See, this problem is from Pigeonhole principle. This problem is from Pigeonhole principle or based on Pigeonhole principle. Can you answer this? Lalit, okay, back. Lalit is back. Lalit shooted. But let us see whether the answer is correct or not. Shubhratjit says 25. Lalit, Anant Mohan also says 25. Very good. See, the pigeonhole principle says if there are n pigeonholes and if there are n plus 1 pigeons, then some pigeonhole should contain at least 2 pigeons. That is a regular pigeonhole principle, whereas the generalized pigeonhole principle says if there are n pigeonholes and or let there are n pigeonholes, let us put this way, or and also you can write now, and k n plus 1 pigeons, then it's a generalized version, sir. It's 37. Huh? Why people are changing answers, sir? Then some pigeonhole contain at least k plus 1 pigeons. At least k plus 1 pigeons. This is a generalized version. And we can also have one more version of this, sir. If there are n pigeonholes and if there are k pigeons, that is there are n pigeonholes and suppose there are k pigeons, some k is some big number where k is greater than n, my dear friends. Then some pigeonhole contains at least ceiling of k by n pigeons. So these are the two versions which we can use for pigeonhole principle, my dear friends. And using this formula, you can simply do, because how many months are there in a year? How many months are there in a year? There are 12 months in a year. The 12 months are nothing but the pigeonholes. So here k value is this. What you do is 25 by 12 you do it. The ceiling of it. 25 by 12 is 2 point something, which is 3. Now here also you do 37 by 12. 3 point something, which is 4. 36 by 12 seal of this is 3. And 49 by 12 seal of this is 4 point something, which is 5. And out of this, 36 and 25 both are giving the answer 3, but he is asking minimum number. Minimum number which guarantees the result means 25 is the answer, my dear friends. Why Arshpreet 12? Why Arshpreet 12? Is the idea clear? Hope you understand. 25. One second, let me add one slide here to explain some. Banks. See my dear friends, this can also be solved in a general manner. See, whenever there are at least number is given, see, we can guarantee at least k plus 1. He asked at least 3. He asked at least 3. He asked at least 3. That means the k plus 1 value is 3, which means k value is 2. Then the minimum number is given by the formula kn plus 1. If you want to solve it by formula method, then this is the method, sir. K is 2, n we already know which is 12. Therefore, k into 12, that is 2 into 12 plus 1, which is 25. So, whenever this at least number is given, that is k plus 1 value, from that you find the value of k. Then the minimum number is given by the formula kn plus 1. By this formula only, by this statement only you will understand this. By this statement you will understand this, sir. See, you can do this ceiling method or you can do by this method also. Hope you understand. Is the idea clear? The number of ways in which 5 dogs and 3 cats can be arranged in a circle so that no 2 cats are next to each other. It's a very simple, straightforward question. Please answer this, sir. How many ways 5 dogs and 3 cats? So they are pet dogs and pet cats, so they can stay together. Otherwise, cats and dogs will have problem. So some people logically they think when the dogs are there, cats won't be there, so they'll run away. This kind of logical answer they give you. We are not getting into that. They are trained to sit around a circular table. Comment box says 720. Okay. Different people are answering. Good to see. See, whenever you have this question, a very regular, straightforward question, because you are arranging around a circle. First, who are not having any restriction in this problem? Dogs don't have any problem here in this problem. So first arrange 5 dogs in a circle. Shuprajit says 1440. 5 dogs can be arranged around a circle because circular arrangements would be n minus 1 factorial. 4 factorial ways you can arrange. Why we are arranging them, sir? Because they do not have any restriction. They do not have any restriction. Now, if you consider one such arrangement, dog 1, dog 2, dog 3, dog 4 and dog 5, where if you keep cats, no 2 cats will be together. So if you keep the cats, okay, sorry, they are in the circle, I forgot. They are in the circle. Okay, let us arrange them in circle only. Where you keep cats, they are not next to each other in the gaps. See, whenever you have n objects in the circle, there are n gaps. N objects in a line means n plus 1 gaps will be there. In a circle, there will be n gaps only. So, how many gaps are there? 5 gaps. How many cats you have to arrange? 3 cats. 3 cats in 5 gaps, which is nothing but 5p3. See, this is for one arrangement. For one arrangement, if it is 5p3, then for 4 factorial, what will be the answer? So, the answer would be 4 factorial into 5p3. So, 1440 is the answer. Very good, Shubhadijit. Okay, 1440 is the required answer. So, is it 1440? 24 into, why 1440? 5p3 is 15 or what? 15. But maximum, I don't think that much, no. Why 1440? 4 factorial is what, sir? 4 factorial is 4 3 is 12, 12 3 is 24. What is 5p3? 5 into 4 by 2. That is 240, no? Why 1440, Anantamohana? We done any mistake in this? 1440 is correct? Yeah, 240 is correct. What is 5p3? Okay, 5 into 4. Okay. I written C. I written. Okay, combinations I written. Sorry. 5p3. No. 5 factorial by 5 minus 3. 2 factorial. Sorry. 5 into 4 into 3. Sorry. I taken C. So 24 into 23 is 60. I think it is correct. I am doing 5C3 combinations. I am doing. Sorry for that. Yeah. Sorry for that. Yeah. Next one. Next question. Yes, you are correct. Sometimes. Next question. No, Ashprit, it is not 240. We both are doing C combination. It's permutation of 5p3. We written 5p3 and I am doing 5c3. You are also doing the same thing. Ashprit, please remove your comment. Okay. Otherwise, teacher and student both are doing same mistakes. Yeah. In an exam of 5 papers, a student has to pass in more papers than the number of papers in which he fails in order to be successful. Am I clear? Now, the number of ways he can be successful. The number of ways he can be successful. What is the answer for this? See, there are 5 papers. A student has to pass in more papers than the number of papers in which he fails in order to be successful. Anant Mohan says D. Anant Mohan says D is the answer. Let us see, my dear friends. Total there are 5 papers. Pass and fail possibilities. Let us see pass and fail possibilities. He can pass in all the 5 papers, then the number of papers in which he fails will be 0. He can pass in 4 papers, then the number of papers in which he fails will be 1. 3 means 2 here, 2 means 3 here, 1 means 4 here, 0 means 5 here. So these are actual possibilities for the student. He can pass in 5 and fail in 0, pass in 4 and fail in 1, pass in 3 and fail in 2. Like this can happen. Now what is that he is asking, sir? He is successful if he passes in more papers than the number of papers in which he fails. So, what are the possible cases where he is successful, sir? In what cases he is successful? If he passes 5 papers, then he is successful. 4 papers also is successful because 4 is greater than 1. Because number of papers in which he has to pass is more than number of papers in which he is failing. 3 is also fine. But these 3 cases, no. So, out of the number of ways he is successful. Number of ways he is successful means the number of ways he passes in 5 papers. So he need to pass in 5 papers, my dear friends. He can pass in all the 5 papers, that is he can select 5, or he can pass in 4 papers, or he can pass in 3 papers. So if he pass in 5 papers, he is successful. If he pass in 4 papers, then he is successful. If he pass in 3 papers, then he is successful. So the answer for this would be 1. What is 5C4, sir? 5. 5C3 is 10. So the answer for this is, why D, sir? Why D, sir? Most of the people are giving D 31. Why? Tushar also given 31. AB also given 31. Huh? You just need to select the number of papers in which he passes, either 5 or 4 or 3. That is the answer. 16 is the answer, my dear friend. Ashprit, correct. AB now changed your answer. Very good. It's not like 5 pass and 5 fail. It's not like the total 5 papers are there. We have to select how many papers. 5 you have to select which in which he passes, or 4 or 3. That is the answer. That's what I'm saying. It's not like, you are having 5 passing subjects, 5 failing subjects, then that what you are thinking might be happening. It's not like that. 5 papers are there. How many papers you need to pass? 5 or 4 or 3 out of 5 papers. That is the idea. See, number of papers are not 10, papers are 5 only. Okay, you may see, for failing one particular student will not increase number of papers. No, papers are 5 only. Papers will not increase. What about next one? The power set of A contains 16 elements. How many elements are there in set A? How many elements are there in set A? Power set of A contains 16 elements. How many elements are there in set A? So we know that if A contains n elements, power set of A contains 2 power n elements. Now the power set of this power set contain how many elements? Because this set contains 2 power n, this power set will contain 2 power n elements. Lalit, check your answer. So now what is given? Power set of A contains 2 power n, that is equal to 16 is given. So 2 power n should be equal to log 16 to the base 2, which is nothing but log 2 power 4 to the base 2, which is nothing but 4 log 2 to the base 2. These two get cancelled. That is log 2 to the base 2 is 1. So 2 power n now would be 4. 2 power n is 4 means what is answer? N value is 2. Is that clear? Lalit changed your answer. Very good. Arshpreet, why 4? Arshpreet. Yeah. We always do mistakes in hurry only, my dear friends. See, I always tell, suppose if we give very big number, people generally don't do any mistakes. Generally people don't do any mistakes. When you give small numbers, now we generally do lot of mistakes. In GATE, you will not find very big numbers, sir. See, generally what can happen, sir? 2 power 2 can ask, 2 power 3 can be asked, that is 2 cube means 8, 2 power 8, 256. This number they can ask you is 256. What is the next number which they can ask? What is the next number which they can ask for this particular question, sir? What is the next number which they can ask for this particular question? This is 256 they can ask. I asked for 16. They can put this number as 256. Then the answer would be 3. 2 power 4 na. So for that what will be the answer? 2 power 16. Yes, 2 power 16 means you all know na. 65,536 something. 65,536 something. That is what happens. Okay. So these are the possible numbers. Actually, if you practice it na, directly, when you see 16 you say 2. When you see 256 you say, because it is power set of E. It is power set of A, not power set of A. Power set of A is 2 power n, but power set of A means 2 power. That you should remember. Good problem. How many subsets with more than 2 elements does a set with 10 elements have? How many subsets with more than 2 elements does a set with 10 elements have? Set is having how many elements, sir? Set is having 10 elements. The question is, number of subsets with more than 2 elements does a set with 10 elements have? Directly if you want to do it, you can do more than 2 elements. A.V. Babu, check your answer. I know that it is more than 2 elements, not greater than or equal to. So with simple problems we are doing a lot of mistakes, right? Get back to the basics. Yes, Subrajit. So more than means actually 10C3 plus 10C4. This is direct way of solving it. Directly if you want to solve it, that is number of subsets with more than 2 elements, that is 3 or more elements. 3 or more elements, that is 10C3. Now how many subsets are having 3 elements are 10C3? How many subsets are having 4 elements? 10C4. And if you continue, it is 10C10, my dear friends. That is direct way. But indirect way, if you want to solve it, total minus, of course the approach is correct, but we made a mistake. 10C0, 0 element subset, 1 element subset, 2 element subset. So total we all know, for a set is having 10 elements means how many subsets it is having? 2 power 10. 10C0 is 1, 10C1 is 10, 10C2 is what, sir? 10 into 9 by 2, 9 5 is 45. So I think when you simplify, the answer should be 968, my dear friends. Please answer this question. Number of binary strings of length 8 which start with 10 or end with? Yes, Lilith. Yes. Number of binary strings of length 8 which start with 10 or end with 11. I think you can take this as homework. We not done any homework problem today, so let us take it as homework. This is homework problem. Next problem. Number of ways of arranging the letters of Katappa in such a way that no two A's are next to each other. No two A's are next to each other. Very old question, no? Old is gold. I am using Katappa from Bahubali 1, my dear friends. Your previous question is homework, sir. So you just keep doing it, sir. I'll just add yesterday's homework problems for completeness, because yesterday homework problems I said I'll do it. This is same. Please answer the question, sir. Meanwhile, I think only 2 homework or 3. I have 1, 2. Let us solve. Yeah. 3, 6 Katappa. Okay, Katappa is very difficult problem. Let us solve Katappa. 3600 Anant Mohan says, the number of ways of arranging the letters of word Kattappa in such a way that no two A's are next to each other. See, in Kattappa, K-A-T-T-A-P-P-A, these are the three A's. No. Why two parts? Only one part, na? Why two parts? Let us solve. See, other than A, how many letters are there, sir? Total 8. Other than A, 5 letters are there. First, arrange remaining letters. Which do not have any condition. Arrange remaining letters. See, in the remaining letters, there are 5 letters, in which 2 same, which are T's, 2 same, which are P's, and 1 is same, which is K. So, these do not have any condition. First, arrange them. This can be arranged in how many ways, sir? Acha, okay, let me check that. Okay. 5 factorial by 2 factorial into 2 factorial into 1 factorial. So, that is nothing but 5 into 4 into 3. 2 factorial is cancelled. And one more 2 factorial means 2 will be there. 5 2 is 10, 10 3 is 30. Okay? 1 2 factorial cancelled, 1 2 factorial will give you this one. 30, correct only? 30 is the answer. That is, the remaining letters can be arranged in 30 ways. Now, if you consider for each of this, okay, let me consider one arrangement. If you consider one such arrangement, that is K, T, T, P, P, where I should arrange A's so that no two A's are together. If you arrange A's in the gap, then no two A's will be next to each other. How many gaps are there? Obviously 5 letters are there, means even if they are repeating, 5 letters are there, means 6 gaps will be there. So you have to arrange 3 A's in 6 gaps. How many ways 3 A's can be arranged in 6 gaps? Here A's are all same. You just need to select the position. You don't have to arrange them, because 3 A's can be arranged only in one way. So 3 A's can be arranged in 6 gaps in 6C3 ways. Actually 6P3 they are different because they are same. First select 3 positions, that is 6C3. You selected 3 positions. In the 3 positions, 3 A's can be arranged only in one way. So this is for one arrangement. 6C3 means, therefore the answer, no 2 A's are together. No 2 A's together. For this the answer would be 30 into 6C3. So what is the answer for this, sir? 30 into 6C3? 30 into 6 into 5 into 4 by 3 into 2 into 1, which is nothing but 20 into 30. 30 into 20, which is nothing but 6. 600 is the answer. Shubhrajit said correct answer. But Ananta Mohan made a mistake. I think you multiplied with 3 factorial, my dear friend. Anant Mohan, you multiplied with 3 factorial. So that's why you got the wrong answer. Because 3 A's need not be arranged. We just need to select the positions for 3 A's. So that is the twist in the story for this problem, my dear friends. I think same question. Okay, we repeat it. Okay, no problem. Yeah, you did 6P3, I understand that. I think same problems. There are next to each other. Okay, same question. So no need of this. Okay, what I do is I'll make it another problem. Okay. 3 A's are next to each other. This is homework. I'll make it a homework problem for you. Number of ways of arranging the letters of word Kattappa such a way that the 3 A's are next to each other. 3 A's are next to each other. Please try this as homework, sir. It's okay, no? Because we already have this problem, I think mistyped, but do it as homework, sir. Try this as homework, numerical answer. The next one, please try this. Number of ways of selecting 10 questions for an exam from discrete mathematics, algorithms and data structures. So I need to create, people are asking me to create questions, my dear friend. 10 questions they are asking me to create, and the subjects given to me are discrete mathematics and algorithms and data structures. Please tell me how many ways I can create the questions. Please help me out. How many possibilities are there for me? Subrajit said 66. Generating function. For this unit, generating function. If you want to use generating function, then I have to put condition like, you can use 1 to 4 books for discrete mathematics, 2 to 5 books for algorithms, then 2 to 4 books for data structures. If I put such condition, then it becomes generating function problem. Otherwise, why we need generating function for this? Seven bits angles. 3C10 he says. 3C10. How can you select 10 out of 3, sir? How to select 10 out of 3? कैसे? क्वेश्चन को ब्रेक करेंगे क्या? See, my dear friends, this is called combinations with repetition problem. This is called combinations with repetition problem. See, the idea here is discrete mathematics, algorithms, data structures. So, discrete mathematics, let us assume that he selected x1 questions, algorithms he selected x2 questions, data structures he selected x3 questions. This sum must be equal to 10. This sum must be equal to 10, where the condition is xi should be greater than or equal to 0. Xi should be greater than or equal to 0. Because I said you have to select questions from these 3 subjects so that total should be 10. I can select 0. See, I don't like discrete mathematics, so I don't select any questions from discrete mathematics. I select all questions from data structures and algorithms only. So when you don't put any condition, it is xi greater than or equal to 0. Default condition. So default condition, it is combinations with repetitions. The formula for this is given by, what is the formula? The number of integral solutions of these equations, which is given by n minus 1 plus RC R. What is n? This is n. What is R? This is R. This is called n and this is called R. So it is 3 minus 1 plus 10C 10, which is 12C10 or 12C2 also you can do it. Yes, 12C2 also, because NCR is nothing but NCN minus R, which is nothing but 12 into 11 by 2, which is nothing but 66. Shubrajit done that very quickly. Yes, Shubrajit, you are correct. You are correct. See, the same problem, if you want to make it, if you want to make the same problem as generating function problem, then you have to put the constraints like, you have to select at least 1 and maximum 4 questions from discrete mathematics. Like that, if you put it, then it becomes generating function problem, my dear friends. If time permits, I will do it towards the end, but otherwise we will continue with this. It's a very bold gate question. So, very popular one. I think most of you might be knowing answer for this, but I'll just do it. So let us try this. Yeah, permutations and combinations with repetitions, definitely I take it, sir, because earlier I taken a session on this counting, basic counting techniques I taken. Okay, recurrence relations also I taken. Algorithms basics like asymptotic notation and performance analysis also I taken session. But advanced counting I haven't taken, like generating functions and this one, like permutations and combinations. That is a very interesting topic. Let us try it sometime. See, mathematics, programming, these are the 2 fellows or 2 subjects which you need to be in regularly touch with them, sir. If you don't be in touch with these fellows or these subjects or these concepts, it would be the same story for anyone. Even whether it is you or me also, the story would be the same. See, this previous question is based on combinations with repetitions. Because you are selecting from 3, 10 you are selecting. This is combinations with repetitions. Combinations with repetitions. 2640, yeah, a very common question. Yes, yes. टाइम कभी नहीं मिलता है यार, ढूंढना पड़ता है टाइम. ओके, टाइम हमें फाइंड आउट करना पड़ता है. सी इफ इट इज योर प्रायोरिटी, see generally I generally follow this theory like priority theory. Suppose you are doing 3 activities, say ABC, okay, you are not able to find time for any of the activity, means that is not in your priority list. Okay, if it is your priority, definitely time मिलना चाहिए. Okay sir, please follow, sir. Thank you. Yeah, I'll try to take some sessions, sir. Some marathon sessions, something I'll tell you. Okay. See, generally when I say motivation classes, people say, sir, ज्ञान मत दो, subject दो they say. So they don't accept my ज्ञान. Only subjective ज्ञान they accept, not other ज्ञाns. Okay. Right. 2 girls have picked 10 roses, 15 sunflowers, and 14 daffodils. You have to help. What is the number of ways they can divide the flowers among themselves? चलो, towards the end, after the class, हम दोनों बैठ के बात करेंगे. Let us see how many people will stay for my motivational lectures. Okay. First, let us complete the story. Towards the end, okay, I address Lalit Yadav. Yeah, I think you attended more motivational lectures. 2 girls have picked 10 roses. Now look here, 10 roses. How can you divide 10 roses among 2 girls? How can you divide 10 roses among 2 girls? 10 roses can be divided among 2 girls. Some people feel very fair enough, like 5. ऐसा कुछ नहीं होता है. Fair enough नहीं होता है. You just ask how many ways you can divide 10 roses among 2 girls. You may give 10 to one girl. It's your choice, no? 0 to other. 9 1 दे सकते हो. Like that you can continue, and finally 0 10 भी दे सकते हो. So how many ways you can divide 10 roses among 2 girls? 11 ways. 10 roses among 2 girls can be divided in 11 ways. It's not 10C to Lalit Babu. No, Satyam Naik says C is the answer. Very good sir. It's not that. Actually, you know, girl 1, girl 2. Assume you given x1 roses to girl 1 and x2 roses to girl 2. So this sum should be equal to 10. And there is no condition here. Each xi can be greater than or equal to 0. Is it not exactly same as this problem? Is it not exactly same as this problem? Got it? And here n is 2 and r is 10. So the formula is n minus 1 plus rc. Either you can write r or n minus 1 also you can write. That is nothing but 1 plus 10, 11, c 1, which is nothing but 11. Okay. See, now for 10 roses there are 11 possibilities. So similarly 15, if you solve it, 15 it would be 16 possibility. 14 daffodils, how many ways you can divide among 2 girls? Sir, 14, one more than that, that is 15 ways. Is that clear? So the answer is 11 into 16 into 15. So I think the answer is 2640. Please multiply. Okay, so I want everyone to try this problem, sir. I want everyone to try this problem. 3 girls, same story, 3 girls picked 10 roses, 15 sunflower, 14 daffodils. Instead of 2, homework is with 3 girls. Homework is with 3 girls. Yeah, please stop, discussing this. Okay. Today I am in good mood, so I am not getting different or scolding you. Please stop doing another discussions in the chat box. Please discuss about what is happening. Help others. Okay? ये करेंगे वो करेंगे बाद में कर लो यार, वो सब बातचीत बाद में करो, प्रॉब्लम का सॉल्यूशन तो दे दो इधर. Okay? So people may deviate unnecessarily. Anyhow, teaching on YouTube is like teaching openly. Okay? Please try this. See, now I made this for 3 girls again. You can try 4 girls, 5 girls, 6 girls, 7 girls. People ask me, sir, practice कहाँ से? यही कर लो, practice. 3 girls दिया, 4 girls कर लो. Now you don't like girls, put boys. And for boys, you don't want to keep the flavors. You can put 3 different types of guns. AK-47, some other gun. Or you can keep some other things, books you can keep. Am I clear? Like that you can do it, my dear friends. Okay? Try it with different things. Okay, recurrence relation, a regular problem, sir. Recurrence relation, solving recurrence relation is a regular problem. So I have given some questions, homework questions. स्निपर्स या पबजी भी खेल रहे हैं तो आपको बहुत सारे डिफरेंट वेपन्स भी मिल जाएगा. ओके, डिफरेंट वेपन्स यू कैन यूज इट. या ललित यादव विथ 3 गर्ल्स इट इज 12C2. 12C2 क्यों हो गया यार? सेम 10 roses means 10 roses for 3 girls. x1 plus x2 plus x3 is equal to 10. So here it is 3 minus 1 plus 10 C 3 minus 1, that is 12C2 for 10 roses. Similarly for sunflowers you have to do, daffodils also you have to do and multiply them. Then you will get the answer, sir. Only for roses, okay, it's fine. Okay, only roses 12C2 is fine. For sunflowers, because you have to share or you have to divide all the types among the girls. Am I clear? Like. So it is, for this recurrence relation, it's a homogeneous one, very simple. What you need to do is write the characteristic equation CT. So generally I say CT bajao. So what happens? It is t square minus 4t plus 3 is equal to shunya. Find the roots. The roots are 1 and 3. See, by seeing the roots you can easily understand 1 power n and 3 power n should be in the solution. See option C which contains both 1 power n and 3 power n. This is wrong. 4, this is wrong. None, we have to wait, we have to check this. That is the only fellow which contains 1 power n, 3 power n. But this none is a very dangerous option, sir. None is a very dangerous option. Am I clear? So you have to check whether it is correct or not. So Tn is equal to, so that is the only possibility now, 3 power n minus 1. Check whether both the conditions are satisfied or not. If both the conditions are satisfied, then this is the answer. So let us see T0. What is T0? 3 power 0 minus 1, which is 1 minus 1, 0, satisfied. T1 means what, sir? 3 power 1 minus 1, which is 3 minus 1, which is 2, satisfied. So this is the correct answer. See how simple it is. See, mostly they are not troubling much with this combinatorics questions, my dear friend. Very simple questions only they are asking. Am I clear? Maybe 1 or 2 variant questions they are asking. Okay, but if you can think properly, they can also be answered very easily, my dear friends. Mostly the questions from discrete mathematics comes from logic and graph theory, but combinatorics they mix and match with the other topics mainly, sir. Mainly they mix and match with the other topics. And generating function questions they are asking regularly, sir, but due to time factor, because when I take any topic like generating function, I should know whether you know that particular topic or not. Otherwise it is just I take a problem, I solve it and I go. Okay, so that's why I have not taken any generating function problems. Here we can take this problem as generating function problem. This type of problems can be converted to generating function problem, where we need to make the condition like, so discrete mathematics, there may be some conditions like this. Algorithms, there may be some conditions like 7, and data structures, there may be some condition minimum 3 and maximum 10. Like this, if you do it, the same problem converts to a generating function problem, my dear friends. characteristic equation. See, the idea for characteristic equation is it is up to Tn minus 2. It is a second order or second degree, people call it second degree recurrence relation, sir. It is going up to n minus 2, no? So you start with second degree polynomial t square. You start with t square. You start with t square. See, next t square, next term is t, next term is constant, and the coefficients are simply this fellow coefficient 1, you keep it here. This fellow coefficient is minus 4, you keep it for this. Constant coefficient you keep it for last and equate it to 0. That is characteristic equation by difference. You can try other problems like Tn minus 3Tn minus 1 plus 2Tn minus 2 is equal to 0. Here also same thing, t square, t and constant. Here coefficient is 1, here coefficient is minus 3, here coefficient is 2, equal to 0. Like this we can easily get the characteristic equation by difference. Actually the characteristic equation, if you want to get it, that method is by using generating function methods. Okay, ultimately we just need to understand recurrence relation, how you solve it by difference. There is some noise background today. Funny. This is an interesting question, sir. Tomorrow there is no class because I have some paid session going on, and Sunday we will take class, that is for sets. Sets is already done. Sets is done? No, not done. Sets, relations and functions. Sets, relations, functions, if possible groups. Some questions on groups. Maybe 1 or 2 questions. So that is on Sunday, sir. Sunday 8 p.m. 8 or 8:30, I don't know. I just check it out. 8:30 I think, sir. 8:30 we have this particular session, sets, relations and functions. And on Monday we have graph theory, sir. Okay, on Monday we have graph theory, same 8:30 p.m. Okay, tomorrow's class I'll announce, I'll again send you this particular notification in the Telegram group, sir. CS_Sridhar. CS_Sridhar is the Telegram group. Marathon session will take, again same problem, same thing will happen, sir. So marathon session I plan some important topic, थोड़ा extra problems लेने की कोशिश करेंगे. CLR, sir. Is it CLR means algorithm loop you are referring to? Okay, homeworks let us solve. Lalit Yadav, you remember the answers. That is good, but very bad. Because the answer for this is not 98, it is one number missing. You know what is that one number missing? It's a homework problem for you. So even if you solve it, the answer is wrong. This is AN. This can be written as, okay, anyhow, let me solve it. Why to write homework? Simple problem. Let us solve it. Let me solve this problem. See, here I can write it as an minus 1 is equal to 6n square plus 2n. Now just use your iterative method, sir. an minus 1, no? So in place of n you put n minus 1. This is an minus 1, this is an minus 2. See what is happening when n is there, this n square, this n is coming. Is the idea clear? So what happens when you have n minus 1? It is 6n minus 1 whole square plus 2 into n minus 1. And you have to continue this story, my dear friend. How long you can continue? Till a1, because a1 is the base condition is given. So a1 means you should continue till a2 minus a1. And before this, what is the before term, sir? a3 minus a2 is the before term, my dear friends. See, when it is n, it is 6n square plus 2n. Similarly, it is a3, it is 6 3 square plus 2 into 3. And it is a2 means 6 2 square plus 2 into 2, my dear friends. See, when you add all of them, all this will get cancelled, and you left side you end up with only an minus a1, adding all this. No, cut हो जाएगा, yeah. Taking 6 common, so 6 common लेने से क्या होगा? n square plus n minus 1 whole square plus and so on 2 square plus, and 2 common line say it is n plus n minus 1 plus and so on plus 2. See my dear friends, I am associated with BYJU'S from past 1+ years, but with live sessions and all I am started very recently my dear friends, because I am busy with the other one. So I may not know about every faculty here, so sorry if I don't know that particular faculty, okay, because there are around 40 to 50 faculty are there. So maybe after this GATE examination we have a big get together where we come and meet each and every faculty, then I can tell you next time. So because starting from the live session I am continuously taking live somewhere here or there, and I am also having continuous recording session, so not known about all faculty here, sir, okay. So mostly interacting with you people only, okay. 6 into, what is the sum of squares of first n natural numbers? Actually 1 square is missing, no, you can add 1 square and subtract 1 square, and sum of squares of first n natural numbers is n into n plus 1 into 2n plus 1 by 6. Means I added 1 square, then you get the formula, but you need to subtract that 1 square, my dear friends. Then similarly here 2 into, here also 1 is missing na, plus 1 minus 1, plus 1 करने से क्या होगा, n into n plus 1 by 2 minus 1 हो जाएगा, okay. So like this you will get the answers. Now if you simplify this, a1 is 8, okay. I think I don't have space. Did I kept an additional slide for this? No, I didn't get. Okay, let me keep additional slide for this. So now what is happening, sir? an minus a1 is 8. So when you expand this, what happens? 6 cancel, you get n into n plus 1 into 2n plus 1 minus 6 is there. So that minus 6 and this minus 2, that becomes minus 8, sir. This 2 cancels. This is plus n into n plus 1 and minus 8. 6 minus 2 is 8. These two get cancelled. So you get an is equal to, taking n into n plus 1 common, this is 2n plus 1 plus 1, which is nothing but n into n plus 1 into 2n plus 2, which is an value, my dear friends. So this is an value, and it says a 99. 99 you put n is equal to 99. 99 into 99 plus 1 is 100. So 2 into 99, 198 into 2, 198 plus 2 is 200. So this is nothing but 198 into 10 power 4. So the value of k is, because he written it as k into 10 power 4, so the value of k is 190, what? 198. Oh, what happened to the people? Did I taken more time than usual? 198. So homework problem, which one is true? So let us solve this. See here what we can do is, first one, f implies a, negation a. By modus tollens this becomes negation f. F implies a, negation a, it becomes negation f. Now you take this c implies f. Negation f, c implies f gives you negation c. Now you are having this b implies c. Negation c, b implies c will give you negation b, which is correct. So S1 is correct, my dear friends. S1 is correct. What about the next one? Whether it is correct or not. Let us check this, my dear friends. Here itself. See, negation a and b, by simplification rule, you can get negation a as well as b, my dear friends. Okay. Now we have c implies a. Negation a and c implies a will give you negation c. Now you have this negation c implies d. So these two gives you by modus ponens d. Now d is there and d implies e is there. These two will give you e. And e is the answer which is required. Yeah, it is also correct. Both are correct. Both S1 and S2 are correct. C is the correct answer for this. Both are correct. And number of lines in which this particular proposition is true. How many lines this particular proposition is true, my dear friends? How many lines this particular proposition is true? The variables P, Q, R, S. See, actually it is an implication. An implication can be false when this is false and this is true. When this is false, S should be false and all these fellows must be true. Then it would be false. That is, it is false only in this particular line. But when you have 4 variables, there are 2 power 4, 16 lines. So in the remaining 15 lines, what should happen to this? It should become true. So the number of lines in which it is true is 15, my dear friends. Number of lines in which it is true is 15. Lalit, it is 15. Hope I answered. Anant Mohan, you asked for solutions. I solved both the problems, sir. Any more question which I missed, please let me know that. If I miss any other question, please let me know it, sir. Otherwise, that's all for today. So, tomorrow there is no session, sir. Actually, there should be a session actually, but due to my other engagements, I am not taking tomorrow's, but on Sunday, I will be taking the session. So, that's all for today. Thank you, my dear friends. Thank you. Any doubts, please ask me. Otherwise, with background music, we will conclude today's session. Thank you, sir. And this particular PDF will be available. Yeah, someone want to have some motivational session. There are some scholarship test is happening, sir. For those who want to join BDP team, there are some scholarship test is going on. You can join that and to get good discounts, my dear friends. Thank you very much, sir. Thank you. Good night. What motivation? What is your doubt? You ask me, I'll answer your doubts. You ask me, I'll answer your doubts. Anyhow, there is some sound pollution here. Lalit, you can send me your doubts on this number 55448. Let me check once, because it should not go to some other people. Eight 1066. Okay, 54488. Sorry, 54488. So this is about it. Please send your message. I'll be answering. Thank you, sir. Thank you for today. Thank you. Thank you very much.